Ever wonder how a self-driving car could literally see a stop sign, but think it's a yield sign? Or how a facial recognition system might mistake a photo of your cat for your face? That's the wild world of adversarial attacks, tiny, almost invisible changes to images that mess with AI. But here's the twist. Researchers just found a clever way to fight back, and it's hiding in your photo app. So how do these attacks work? Imagine you're looking at a picture of a panda. Now someone adds a few pixels of noise that you can't even see. To you, it's still a panda. But to the AI, it's suddenly a gibbon. That's an adversarial attack, like a magician's trick but for machines. But why would anyone do that? Well, AI is everywhere. Autonomous cars, medical scanners, even security systems. If an attacker can fool these systems, the consequences could be serious. That's why scientists are racing to build defenses. And the latest breakthrough. Compression. You know compression. Like when you send a photo, and it gets smaller so it loads faster. Turns out that same tech might be one of the best ways to protect AI. Here's the secret. Not all compression is equal. If you compress an image in a way that keeps it realistic, like, almost indistinguishable from the original, it's way harder for attackers to mess with the AI. Here's why. Adversarial attacks work by adding noise to images. But if the image is compressed to look normal, that noise gets blurred out. It's like giving the AI a pair of sunglasses. Suddenly, the sneaky tricks don't work anymore. The researchers tested this by using different compression methods. They found that models which kept images looking too fake, like blurry or distorted, were easy to fool. But the ones that recreated photos with high realism, they stood strong, even against the most powerful attacks. So what does this mean for the future? It's not just about making AI smarter, it's about making it safer. By focusing on how images look, not just how they're stored, we're building defenses that work with the way humans see the world. And the best part? You're already using this tech every time you share a photo. Next time you compress an image, remember, you're not just saving space. You're helping AI stay one step ahead of the bad guys. And that's the power of keeping things real. Hey everyone, ever wonder how AI can be tricked into seeing things that aren't there? Today, we're unraveling a fascinating puzzle in AI security. How do we protect smart systems from sneaky, ever-evolving attacks? Let's dive in. So imagine training an AI to spot cats in photos. Now someone adds a tiny, almost invisible speckle of noise to a cat picture, so subtle we'd never notice. But the AI, it might suddenly think it's looking at a dog. These are adversarial attacks, clever tricks that exploit the way AI sees. The real kicker. Some defenses that work against basic attacks fall apart when attackers get smarter. That's where adaptive attacks come in. Think of them as hackers who study your security system and build a custom key to unlock it. Now, how do researchers fight back? Let's break down the top strategies. First, architecture improvements, like redesigning AI brains to be more resilient, inspired by how our own eyes process light. Then there's adversarial training, where models practice on both normal and poisoned images to get tougher. But here's the catch. Even these models can crack under pressure, and they often struggle with regular photos. Enter adversarial purification, a clever cleanup step that tries to scrub images of sneaky noise. Some methods use diffusion models, which are like AI artists that can generate realistic images. They push corrupted photos back into the real world, but there's a problem. Diffusion models are slow and expensive, like luxury cars for image processing. Plus, if a defense is too complex, it might not actually be secure. Smart attackers could still find a way around it. Here's a key lesson from the research. Defenses that aren't tested with strong, tailored attacks often look tougher than they are. For example, a purification method by Nye et al. Was later cracked by Lee and Kim, but the latter only tested it against the specific attack that defeated the first. No new tricks. No real security. So how do researchers keep up? They use tools like RobustBench, a leaderboard tracking which models survive the toughest attacks. But even top models can be fooled by adaptive attacks. This shows we need rigorous testing, not just flashy defenses. And here's a wild twist. What if making images look more realistic could actually make AI more secure? New research suggests that compression tools prioritizing realism, not just clarity, might help AI trust what it sees even with tiny tweaks. But there's a trade-off. Balancing speed, quality, and realism is like juggling flaming torches. The takeaway: AI security isn't a one-size-fits-all game. It's an arms race between defenders and attackers, where adaptability is key. As AI powers more of our world, understanding these vulnerabilities isn't just smart, it's essential. Thanks for watching. If you want to see how